Every night, you die a little. Your conscious mind fades into darkness, and for hours, you cease to exist as the person you know yourself to be. But something else awakens. In that void, another version of you emerges, one that can fly, breathe underwater, speak languages you've never learned, or find yourself back in your childhood home that somehow has infinite rooms. You're dreaming, and it's one of the strangest things your brain does. We spend roughly 6 years of our lives dreaming, if you calculate the time spent in REM sleep across an average lifespan. That's about 2 hours each night, adding up to more time than we spend eating, exercising, or even socializing. Yet despite decades of research, scientists still debate why we do it. Dreams feel important, like messages from somewhere deep inside us. But are they? Or are they simply the brain's activity during sleep, a byproduct with no clear purpose? This is the paradox of dreams. They feel significant, yet their function remains contested. They seem random, yet patterns emerge. They're intensely personal, yet remarkably universal. So what exactly happens when we dream? And more importantly, why? The architecture of sleep. To understand dreams, we first need to understand sleep itself, because dreams don't happen in isolation. Sleep is not a single state, but a carefully choreographed cycle that your brain moves through every night, roughly every 90 minutes. When you first fall asleep, you enter light sleep, a transitional phase where your muscles relax and your heart rate slows. Then you sink deeper into what scientists call slow-wave sleep, or deep non-REM sleep. This is the restorative phase, where your body repairs tissue and consolidates immune function. Research since 2012 has revealed that during this stage, your brain also clears metabolic waste through a system called the glymphatic pathway. Cerebrospinal fluid flows through spaces around blood vessels, washing away toxic proteins that accumulate during waking hours. The process works best during deep sleep, when your brain's extracellular space expands by about 60%, allowing more efficient waste removal. But then, something remarkable happens. About 90 minutes after you fall asleep, your brain suddenly becomes wildly active. Your eyes start darting rapidly beneath your closed eyelids. Your breathing becomes irregular. Your heart rate spikes. And yet, your body remains largely paralyzed. You've entered REM sleep, named for those rapid eye movements, and this is where the most vivid and narrative dreams typically occur, though dreaming can happen in other sleep stages as well. During REM sleep, your brain shows high levels of activity on an EEG scan, similar in some ways to waking patterns. The visual cortex activates as if you're seeing. The motor cortex fires as if you're moving. The emotional centers, particularly the amygdala, become highly active. But there's one crucial difference. The dorsolateral prefrontal cortex, your center for logic and critical thinking, shows reduced activity. This may explain why dreams feel so strange. You accept impossibilities without question. You don't realize you're dreaming. The rational gatekeeper has stepped aside. You cycle through these stages 4 to 6 times each night, but the ratio changes. Early in the night, you spend more time in deep sleep. Later, REM periods grow longer and more intense. Your final REM cycle before waking can last up to an hour, which is why the dreams you remember tend to be the ones right before you wake up. But here's the mystery. Why does your brain do this? Why not just stay in deep sleep all night, getting maximum restoration? Why does evolution preserve this bizarre state where your brain burns almost as much energy as when you're awake, constructing elaborate fictional realities that vanish the moment you open your eyes? The theories. What science thinks dreams are for. Throughout history, humans have believed dreams were messages from gods, glimpses of the future, or visits from the dead. We've built entire systems of meaning around them. The ancient Egyptians had professional dream interpreters. Indigenous Australian cultures spoke of the dream time, a parallel reality where creation occurs. Sigmund Freud proposed that dreams were the royal road to the unconscious, though his specific theories have not held up to scientific scrutiny. Modern neuroscience has moved toward testable hypotheses, but scientists have not settled on a single answer. Instead, we have several competing theories, each with supporting evidence, and the truth may involve multiple functions working together. One prominent theory suggests dreams play a role in memory consolidation. During the day, your brain is bombarded with information. Research shows that when people learn a new skill and then sleep, they often perform better the next day than people who stayed awake. Brain scans reveal that neural patterns active during learning reactivate during REM sleep, but faster and in different combinations. This suggests your brain may be rehearsing and strengthening important connections. Recent studies from 2024 have shown that people who report dreaming demonstrate better emotional memory processing compared to those who don't recall dreams, providing new evidence for this theory. But memory consolidation doesn't explain everything. Not all dreams relate to recent experiences. Sometimes you dream about people you haven't thought about in years, places you've never been, or scenarios with no obvious connection to your waking life. This leads to a second hypothesis: emotional regulation. Your amygdala becomes hyperactive during REM sleep, while the prefrontal cortex shows reduced activity. Some researchers propose this allows your brain to process difficult emotions in a safe environment. Research has found that people deprived of REM sleep show increased emotional reactivity and difficulty regulating moods. A 2024 study published in Scientific Reports found that people who dream show both enhanced memory for emotional events and reduced emotional reactivity to negative images the next day, suggesting dreams actively help process and defuse emotional experiences. Even this doesn't explain everything about dreams. Why the strange narratives? Why the surreal logic? Why do we dream in stories rather than just processing emotions or memories abstractly? A third hypothesis proposes that dreams function as simulations. According to this threat simulation theory, your brain runs scenarios, practicing responses to challenges in a consequence-free environment. This idea is supported by dream content studies across cultures showing that many dreams involve some kind of threat, pursuit, or conflict. From an evolutionary perspective, this could have provided survival advantages. An early human who mentally rehearsed being chased by a predator while sleeping might have been better prepared when the real situation arose. However, some researchers suggest dreams might not have a singular adaptive function at all. According to the activation synthesis hypothesis, dreams could be the brain's attempt to make sense of somewhat random neural activity during sleep. Your cortex receives signals and does what it evolved to do: construct a coherent narrative. The result is the surreal but compelling stories we call dreams. It's important to note that these theories aren't mutually exclusive. Dreams may serve multiple functions simultaneously, or different functions at different times. The scientific consensus is still forming, and research continues to reveal new insights about this mysterious phenomenon. The content. What we actually dream about. If you could collect all the dreams of all the people on Earth and analyze them, striking patterns would emerge. Despite vast cultural differences, research shows humans dream about remarkably similar themes. Most dreams are not fantastical adventures. Studies using the Typical Dreams questionnaire have found that the majority of dreams take place in ordinary settings, familiar locations, with people you know. You're rarely the hero of an epic quest. More often, you're simply going about mundane activities, talking to a friend, walking through a building, trying to find something you lost. But certain themes appear universally across cultures and time periods. Being chased is one of the most commonly reported dream scenarios worldwide. Falling appears frequently in dream reports across different populations. Other universal themes include being unable to move, arriving late, being inappropriately dressed or naked in public, and losing teeth. Research from Germany tracking dream themes from 1956 to 2000 found remarkable stability in these patterns over time. Why these specific scenarios? Researchers propose these may tap into fundamental human concerns. Being chased could relate to ancient predator avoidance instincts. Falling might trigger our fear of injury. Social embarrassment dreams, like being naked in public, may reflect concerns about status and acceptance in social groups. A 2024 study found that being chased dreams correlate with negative relationship experiences in waking life, suggesting these dreams may be metaphorical expressions of emotional states rather than literal representations. Interestingly, dreams also change across the lifespan. Children's dreams are shorter and more static, often featuring animals. By age 7 or 8, dreams become more narrative and complex. Teenagers begin to have more socially oriented dreams, reflecting their developing sense of identity. Adults dream about work, relationships, and responsibilities. And older adults report dreams that are often more pleasant and less emotionally intense, as if the brain grows gentler with itself over time. There are also individual differences. People with certain personality traits have distinct dream patterns. Those high in openness to experience have more vivid, bizarre dreams. Anxious individuals have more dreams involving threat and pursuit. Creative people report more lucid dreams, where they become aware they're dreaming and can sometimes control the narrative. And then there's the question of whether we dream in color. Most people do, but it's a surprisingly recent phenomenon historically. Studies from the 1950s found that many people reported dreaming primarily in black and white. Researchers believe this was influenced by black and white television and film. Our dreams reflect the media we consume, suggesting they're not entirely internal, but shaped by culture and experience. The mystery of lucid dreams. For most of human history, dreams were something that happened to you. But some people occasionally experience something different. They become aware, mid-dream, that they're dreaming. The impossible becomes a clue. Wait, I can breathe underwater. This must be a dream. This is lucid dreaming, and it's one of the most intriguing phenomena in sleep research. In a lucid dream, parts of the prefrontal cortex partially reactivate while you remain in REM sleep. You gain self-awareness and potentially some degree of control, though rarely complete control. You might decide to fly instead of fall, confront the monster chasing you instead of running, or explore the dream landscape deliberately. Research indicates that approximately 55% of people report having experienced at least one lucid dream in their lifetime, with about 23% experiencing them monthly. Student populations show even higher rates. With practice and specific techniques like reality checks during the day, keeping a dream journal, or using the wake back to bed method, some people can induce lucid dreams more regularly. But lucid dreaming raises profound questions. If you become aware in a dream and can influence it, who is the you doing the controlling? Your conscious self has re-entered a space constructed by your unconscious mind. You're simultaneously the architect and the visitor of your own mental world. Some researchers believe lucid dreaming could have therapeutic applications. The idea is that people with recurring nightmares might learn to confront their fears within the dream itself. Preliminary studies suggest this approach shows promise for conditions like PTSD and anxiety disorders, though more research is needed to establish its efficacy. Others see lucid dreaming as a tool for creativity and personal exploration. However, there's also an open question that concerns some sleep scientists. If dreams serve important functions like processing memory and emotion, does deliberately taking control interfere with those natural processes? Some research suggests that frequent attempts to induce lucid dreams might affect sleep quality, though the evidence remains mixed. The relationship between lucid dreaming and overall sleep health is still being investigated. The philosophy of dreams. Are you real right now? Dreams blur the line between reality and illusion in ways that have troubled philosophers for millennia. How do you know you're not dreaming right now? This isn't just an abstract thought experiment. It's a question with real implications. The ancient Chinese philosopher Zhuangzi told a famous story. One night, he dreamed he was a butterfly, fluttering happily through a garden. When he woke, he had a disturbing thought. Was he Zhuangzi who dreamed of being a butterfly? Or was he a butterfly now dreaming of being Zhuangzi? The dream had felt completely real. His waking life now felt just as real. But what if reality itself was just a more stable, consistent dream? This isn't mere wordplay. Modern neuroscience shows that the brain processes dreams and waking experiences using the same systems. The visual cortex fires the same way, whether you're looking at a tree or dreaming of one. The emotions you feel in dreams activate the same circuits as waking emotions, which is why you can wake up with your heart pounding from a nightmare. In other words, subjectively, dreams are real while you're in them. The only difference is continuity and coherence. Waking reality follows consistent rules. Dreams don't. But to the dreaming mind, that inconsistency isn't apparent. You fully believe you're experiencing reality until you wake up and realize it was all fabricated. This has implications for consciousness itself. If your brain can create a fully immersive, subjectively real experience out of nothing while you sleep, what does that say about your waking experience? How much of what you perceive as real is also constructed, interpreted, and filtered through your brain's expectations and models? Some philosophers and neuroscientists argue that all conscious experience is a kind of controlled hallucination. Your brain doesn't passively receive reality. It actively predicts what should be there and then adjusts based on sensory input. Dreams are what happens when that system runs without external input, revealing how much of your experience is internally generated. This is not solipsism. The external world exists, but your experience of it is always mediated, always constructed. Dreams show us the machinery behind that construction. The forgotten world. Perhaps the strangest thing about dreams isn't that we have them, but that we forget them so quickly. You can wake from an incredibly vivid dream, feeling like you've lived through an entire experience, and within minutes, it's gone. By the time you finish breakfast, you can barely remember you dreamed at all. Why does this happen? The answer appears to be neurochemical. During REM sleep, levels of norepinephrine, a neurotransmitter crucial for encoding new memories, are significantly reduced. As a result, the neural activity of dreaming isn't consolidated into long-term memory the same way waking experiences are. Dreams are, in a sense, written in disappearing ink. But some dreams do stick, usually because they triggered strong emotions or because you woke up during or immediately after them. The dreams you remember are a tiny, potentially biased sample of your total dream life. Studies using sleep laboratories show that people dream far more than they realize. If you wake someone during REM sleep, they can report dreaming about 80% of the time. But if you wait until morning, most of those dreams have vanished without a trace. This creates an interesting possibility. You might have rich, complex dream lives that you simply never remember. Perhaps every night, you live other lives, explore impossible worlds, and experience things that would astonish your waking self. But by morning, it's all erased, leaving only fragments and feelings. Some cultures take this seriously. Indigenous communities in places like Malaysia and the Amazon have traditions of sharing dreams each morning, collectively remembering and interpreting them before they fade. In some traditions, dreams are considered just as real as waking experiences, perhaps more so, because they reveal truths hidden by everyday concerns. In contrast, modern industrial society treats dreams as irrelevant, something to be forgotten as you rush into the day. We've traded dream recall for productivity. But maybe something is lost in that exchange. Maybe the forgetting isn't just a biological quirk, but a choice our modern lifestyle enforces. What dreams tell us about being human? Dreams are one of the few universal human experiences. Every culture dreams. Every person who sleeps long enough enters REM sleep and generates these strange internal narratives. Dreams are as fundamental to being human as language or tool use. Maybe more so because even infants dream before they can speak or hold objects. And yet, dreams remain deeply personal. No one else can experience your dreams. They're the most private space you have, more private than your thoughts because you're not even fully aware of them. They're a window into parts of yourself that your waking mind never sees. This is what makes dreams so philosophically and emotionally significant. They remind us that we're not unitary. There's a part of you that constructs these elaborate fictions every night, that populates them with people and places, that creates emotions and tensions and resolutions. And that part operates largely outside your conscious control or awareness. In dreams, you meet aspects of yourself you might not recognize during the day. The anxious version who still worries about high school. The adventurous version who isn't afraid to jump off cliffs. The creative version who can speak in metaphors and symbols. Dreams show us that identity is more fluid, more layered, more mysterious than we usually acknowledge. And maybe that's the real purpose of dreams. Not memory consolidation, not emotional regulation, not threat simulation, though they might do all of those things. Maybe dreams exist to remind us that consciousness is stranger than it seems, that the boundary between reality and imagination is thinner than we think, that we spend a third of our lives in a state we barely understand, creating worlds as complex as the waking one, and then forgetting them entirely. Every night, you become an architect of impossible worlds, a storyteller who conjures characters and plots without trying, a philosopher who accepts contradictions without question. And every morning, you wake up and return to a world of logic and consistency, and forget that you're capable of anything else. But the capacity remains. The dreaming mind is always there, just beneath the surface, waiting for you to close your eyes and let it speak in its strange, beautiful, incomprehensible language. Dreams are your brain's nighttime stories, and even if you don't remember them, even if they seem to mean nothing, they're part of what makes you human. You are the dreamer and the dream, the storyteller and the story, living two lives simultaneously, one that makes sense and one that doesn't, both equally yours. Love this video? You may also want to get the beautifully illustrated children's book version. Why We Dream is now available for ages 6 to 10, with 35 pages of magical watercolor art that brings the science of dreams to life. Perfect for bedtime reading and parent-children bonding. Check link in description below.